Hey there, everybody. Nice to see you. This is episode 1 of Project 3 of the Joy of Functional Game Dev. And this time we are doing something completely different, which is we are stealing somebody else's game. It's not exactly stealing because it's on GitHub and I can fork whatever. As it turns out, from the last project, my SDL wrapper got used in a talk here by this person as well. These two fine persons. You can go here. I've got a link in the description. You can go watch it, and they mentioned my wrapper and that they used it and asked if I was in the audience. No, naturally I was not. But as I'm on the wrong side of the Atlantic Ocean. But so I then took a look. What I did is I forked the repo where the game that they made is in and started looking at it and said I'm going to refactor it, and that's what Project 3 is going to be. So let us get started, shall we? And we'll get to things as we go. Where'd I go? I went away. All right, there's is a game called Treatz, and I only have one controller, but that's okay. Visual Studio thinks about things. All right. Okay, thinking about things. They're up, and the controller dies right at that moment. Thanks, controller. All right. So here we are. Treatz. Press any key to start, and I am the little dude, and you're supposed to get the dragons who are eating candy canes that are flying out of the logo for Turkey. And you can put out foam that keeps the dragons from being able to move so that you can get them more easily. And then the other controller controls this player. This right here is the score. And as you can see, even with the other player not doing anything, she is grabbing up some score. But so, all right, simple enough game. Let's take a look at the code and what it looks like. And if you are familiar with the Spore Island Interloper from Project 2, you will start to see here at the bottom, in the main function, some stuff that looks very, very familiar, which is the stuff where you're making where we are making all of the resources using the SDLFS wrapper. And this is where we shall start pretty much immediately. Because as we go through, I know hardly anything about the code base. I know a little bit because I watched the presentation. But other than that, let's just see how we can do. So the very first thing that I'm seeing is that these lines all look surprisingly similar. So step 1, let's do this. And let load bump equal and file name, which is a string, is name and pipe it into that right there. And of course, we'll load bump. I don't know what a load bump is. So, Alt. What we're going to do here is we're now going to, this is the furthest one, I think. Bump, like so. Alright, okay. We are going to do this and go up. Put those in there. Similar thing going down. And let's see that it still works. We appear to, so moving right along. Well, here's another one. And we're gonna seek dot writer like so. I think that's gonna work. Yes, that's going to work just fine. Well, let's get this off of here. This is called Treatz. And so on and so forth. We can leave that there, whatever. Okay, cool. Yeah, just going through, seeing things. So obviously, this is backwards. I mean, obviously. And actually, I'm going to return bitmap. Because I'm going to do some magical things here. Okay, we're going to take the word magenta. We're going to do paste all that in. We're going to and for the moment, I don't have it quite right. For the moment, we need to actually we'll just do this so that for now we're cool. See, the thing here is it's this one, right? And so lining things up just as the various F# zealots insist that we do. But we can very quickly see that is always the same. If that is always the same, then, and also always pointer, then we need let bump to text, which takes a bump, is bump.pointer and pipe into that. And we'll have it's going to be an SDL surface.surface. L surface.surface. And now this is not getting used. So, all right. And for our next trick, we're going to take off all the pointers. As a replace would be faster-ish. To text. And of course I picked the one furthest out so that I could have some of this trick going on. And yes, sir, I did see that dot. Okay, and put a space in its place. So already we are at we got some stuff here. So if we also say, so turkey drag treat tiles Juanita and foam up to here. The rest of these things are the UI elements. Because we reversed the order here, if we take this and we say, gonna pipe in set key magenta, and then do the bump to text. And because we're skipping a step, we move this on over here. We don't have to do any of this nonsense right here. And additionally, I have got no reason in the world. What does this give me? Pointer from surface. Okay, it does give me another pointer, and that's it's been a while. It's been over a month since I've looked at some of this stuff. So, SDL texture from surface. Do a look from surface. Go to the next one. So, actually, this should be a using, because this is a yeah, this is disposable. Really, these should be uses. And yeah, still not ideal, because now, all right, the main texture can be, let's get this a little more readable. And because this part is the setup, right? It can be done right up here. This is the setup for our environment is all of this stuff. And then, so is this really. And then these are all, oops, these are some utility functions to allow, okay, just like those, right in there. And the bitmaps need to be disposable, and the textures need to be disposable. But, and, well, there's only so much you can do with that. All right. Hating this. Actually, I think I want the comma. That's what I want. Yep. So, I really kind of like this there better. And Not strictly necessary, I guess, for those semicolons, but so, okay. That is cleaned up somewhat. Let's see if she still runs, because that's going to be my, it's always the check, right? Okay, and, yep, you still work. All right. Neat. And, yep, it's really... dude fussing. I'm dude fussing over spaces. Usually actually very critical of people who do this, but not today. I know there's faster ways of doing this. There's not that many lines. Okay. So, alright, cool. So that is all cool. And then it goes to an event pump. So my context, which is a rendering context, that should be defined in here somewhere, right? Texture surface. Oh, that's just the, my main renderer. All right, this is the guy that does the default state. What are you? Go to the definition of default state. So one of the things here. This is his way of saying agents or entities or whatever, which is fine. Call it what you like. There's this turkey angle. Milliseconds. All right. Ending data in the last frame ticks equals get ticks. And where's get ticks? Still need to yep. And prepare the level. And what does prepare the level do? Go to the definition. So, all right. Interesting. All right. This is your set of mountains. Where else is mountains used? Mountain. So, all right. So that contains then aux. Rec aux. Okay. So, all right. This is creating the stuff. So this is an interesting. Here is your level or whatever. And that's all fine. Dragon, blood, okay. Gen returns what this returns. Okay. So for me to understand what we're doing, I'm going to go, this one is generate. And so aux is just a thing. P is a position. Ac, as is usual, is an accumulator. And things start to become and if that, then we're going to do it this way just because we can. So that contains position S, so it must be set. Must be set. This must be number. And this must be nope. Rename nor the set. Okay. Rename this one as set as well. That one is also set. We're going to go with I being index. I'm doing this just, oh, yuck. Index. Okay. What is F? Ah, there's our call it a factory method? Yes. So, all right. We'll call it factory. Okay. So generate, it's a number, factory, and aux is a didn't have to. Do we have to do it this way? So aux with our accumulator is not really. So let's watch what happens with accumulator. If you've gotten to the count, then okay, so x equals number set. So it contains an event and index at the set. Otherwise, okay. So what we have here is set is a what? You are a set of ints. Number is an int. Factory is you take a position and you create a thingy. Range and location goes to point P. In position. T is a and blocked. Oh, those are all of the blocked locations. Oh yeah, I see what's going on here. Alright. It's kind of cool, but really, we do this in 2 steps. Step 1, we're generating max dragons. Call it a dragon factory. let dragon factory p equal, and see that. Right. That way, max dragons, dragon factory, mountains. Which is then really mountains. Generate that. Okay. This is position. And I hate you. So I hate it being written that way. So okay. Rules, machine of kinds. We're going to do that, and we're going to do that. So, okay. So then, alright, so I get it blocked. So really there's the output of here be my dragons, and here be my mountains prime. I'm gonna do this. Doke over here. Okay. And so T is a what? Okay, so that's a sure thing. All right. I'm gonna go with blocked. Okay. A lot of little changes here. There's gonna be a better way to do this, and I know. Yep. I don't know yet what it is, but this will be on my list. But so using vector 2. So what's a vector 2 exactly? Go to the definition. Where is vector 2? Oh, okay. He's got these vector 2s. All right. Yeah. All right. Moving along. Well, I've been refactoring some weird stuff here, so let's make sure that it still works and that I'm not completely destroying the functionality as I'm going through. And go. And we appear to still be working, so neat. Mountain. We only, I only need one mountain in my mountain. No, vector, okay. Getting out of control here. Treatz game. Let's go. Oh, where was I? Where was I doing all my stuff? I had my render func, right? My main renderer. No, not my main renderer. No, that's right. I was just someplace. Where was I? Nope. All right. I'm going to go to my event pump. Event pump. I just did a whole bunch of cool stuff somewhere, right? Oh, default state, and then prepare level. So go to the definition. So okay, I still don't have a really good name for ox, because actually this is not. This is a. This is an unfold operation. Is what's going on here, because yes, there's an accumulator, and you're checking it against an index, but really, this is an unfold. Let's see if we can make generate 2. All right, so generate 2, which is a number and a factory and a set. This is, so we have an empty, and our accumulator is really a list, index, and a set. Yeah. So, number, set, list, unfold, set of list. Actually, we could just take the fun that's your index. Oh, main number comma set. Fun remaining set. Which is a list. Why do we still need it? Okay, so we do actually need the, so this does generate gives me a list and a set of things that are already there. Okay, so the set also gets modified. Set, we're going to pass the remaining, existing, we'll call them their products in the set. Where more or less if remaining equals 0, then nope, yep, that's right, because it's really, there's two things. So recursive function is the way to go. Yep, this is not a simple unfold, because our set yep, not an unfold. Okay. I just wanted to see. Double second x and first x. See, 2 point. See, but then you go with x. Killing me here. Position. And your vector 2. See, how many places is vector 2? How many places is vector 2 used? Not that many. So actually, if you had gone with a unit on here, would it have... We're not going to do that yet. Okay. So ox. Yep. Suppose it could also be a... suppose it could be a fold, but I would have to generate a 0 dot dot number minus 1, and then this could be used to fold based on the set. Could also do that, but that's, yeah, this could be a fold operator. It's definitely not an unfold because of the thing, because it's not emitting. All right. So our dragon factory creates dragons. So we say the dragon blocked. We start with mountains, which are the blocking entities. We generate definition of max dragons, and here we are. We're gonna do some stuff here. Float. So width is really just cell height. Float. One of the things that these are our constants, and they're a little globally, you wanna say. So the map is okay. All right. So these are, so wait, if I use my calculator, and I say 64 times 16 equals 1024. And 48, well, that'll be 768. So really, this is pixels. Yeah, all right. Since I always forget. Okay, well, not using px here, but what I am going to use is, because common data is way up here, right? Type cell. And all sorts of hijinks are about to ensue. Change it to a float cell. Okay, so what's a map? That's that times 1.0 cell. Yes, sir. There will okay. This is going. Let's slog through this, shall we? The expression was expected to have a type. So next is no, okay. So wrap bounds. Float down float. So for now, we will divide by 1. This is cell width F. What is cell height F? It is a float. Type float. Oh, cell width. So and why should it? And here's where yeah. So that is float cell divided by 1 cell. Oh, that's 0.0. Okay. Fight. Will that work? No. So we'll divide this one by 1 cell. Units of measure are a harsh mistress. So let's divide by 1 cell. Let's divide by 1 cell. Divided by 1.0. Cell width F. Ow, ow, ow. Okay, again. Wrong one. So the map height. Okay. And so now, these other things, as we change them, the units of measure will start to make more sense. But can we build? Can we run? That's the big deal. And we do. Okay. Okay. What are we doing now? See, now cell width is a cell width is in px. And now this is where everything's going to start to get mad at me. Is it really, though? Is it px or is it px per cell? think it is. Times 1.0 px per cell. I think it is. And this is where more craziness will ensue. Boom. Namespace or module Treatz game is not defined. Yes, sir. This is a, I don't know what in the world you're doing. And it just gave up. Build, clean, build. Yes, it has no idea what I'm doing now. I have... Okay. Expecting the fight double. Oh, it makes it into an int. Sure. See, it is both. See, the cell width. Yep, okay. We're going to undo a little bit of that because it doesn't quite work. Cell width is in pixels. But it is also pixels per cell. Cell width is in pixels. Let's start with pixelating. Let's see, what is if it's got all kinds of what in the world is happening here. Yep. Alright, so I gotta get the Treatz game and get these things. So, divided by 2.0. Which is the scalar. Alright. What's the problem it's having? Float px, no, double. Really? Oh, because those are doubles. Dude. You're killing me here. Alright. Okay. Got that thing to shut up. Alright. Expecting a something. What is W? Pixels squared. I like it. Really? What does size do? Size, da. Oh, I don't. We no longer need this. Okay. So with minus 1 by 1.0 px. Or over here, not developed 1.0 px. Okay. Okay, now we're better. So which one is here? A double. I just do the px. Will that make it be quiet? Yes, it will. 1 px 1.0 px. Okay. Now you. Now you. Now you. Where is Dragon Center with an RE? To the definition. It is a double times double. Okay, so the destination. Okay, go to definition. Just do px here. Oh, that's also going to be 1.0 px. Okay. Okay, cool. So we're all here in Treatz. 1.0 x. So there's a big price to pay if basically you got to commit. You're gonna do units of measure all the way, or you're just not. And I think what has to happen in here is that the vector2 class is going to have to use units of measure. Pretty sure that's what's going to happen. But that's okay. Type mismatch. What is x? X is a px2. I don't need. Aha. See, but so since I've committed. See, and why do you even have this? This is it's cell width and cell height. What are you doing? Okay. Are we okay? We're building. Are we running? Let's run, and then call it quits for the day. And we've successfully sprinkled even more units of measure into the thing. Do you work? Come on, work. I know you're gonna work. Look at you working. Look at you. Boom. Boom. There you are. Get the dragons. But okay, it works. And we've jacked all kinds of stuff up in here. Next time we'll just have more fun. Or we'll see what we can do about this junk. This is ridiculous. Why would you do this? But yes, you could. I will. We can fix it because you've got mountains. You've got mountains in your rendering. But yes, sir. All right. But that's for another time. All right. Thanks for coming along on this journey with me. Project 3 is not like the previous projects where we start from nothing, but I think it's pretty interesting. So we're gonna see how long this trail takes us. Thanks so much for coming on this journey with me. And as always, keep that joy of functional game dev in your heart. And I'll see you next time.